Hey guys, Dean Chase here, coming at you with another geometry lesson. Hope everybody's doing good. Let's go ahead and get this thing started with a word of prayer. Dearly Father, I want to thank you for staying with us, Lord. I want to thank you for all you've done. Please bless us. Please bless my students and help me continue to be the teacher I need to be. I love you, Lord. In Jesus' name I pray, amen. Alright guys, so today we're going to be learning how to identify pairs of lines and angles. This is lesson 3.1, page 147. So, this first slide has a lot of information on it, so I'm going to try and break it down as best as I can. Two lines that do not intersect are either parallel lines or skew lines. Two lines are parallel lines if they do not intersect and are coplanar. Two lines are skew lines if they do not intersect and are not coplanar. Also, two planes that do not intersect are parallel planes. So, here they give us a few examples of parallel lines and skew lines, parallel planes, and so on. So let me go ahead and break this down to you real quick. Two lines are parallel if they lie on the same plane. That means the same dimension, okay? And that's what you've been learning about all your years of school so far. So M and N are going to be parallel because they're like railroad tracks. They're never going to touch. Your teachers always said, you know, parallel lines are like railroad tracks. I'm pretty sure pretty much every teacher who teaches parallel says it's that way. Now, skew lines are probably something new. Skew lines are not parallel and will not touch another line, okay? Because we're dealing in 3 dimensions here. So line M and line K are on different planes, but they're never going to touch because one is running sideways as to where the other one is running up and down. So they're never going to touch. It would be like if my finger was a line and this pin was a line. They're never going to touch because the pin's going up and down and my finger's going side to side. Okay? I hope that kind of makes sense. It's probably really hard to have that dimension in the camera. But then we are going to look at planes. Planes can be parallel. Like plane T and U are going to be parallel planes. They never touch each other. Lines K and N are intersecting lines, and there is a plane not shown containing them. So there's a plane that holds both K and N, but it's not shown. Small directional triangles as shown on the line M and N above are to represent parallel. A lot of times when you write it, the symbol right here means it's parallel to, as in M is parallel to N. Segments and rays are parallel if they lie in parallel. Segments and rays are parallel if they lie in parallel lines. A line is parallel to a plane if the line is in a plane parallel to the given plane. So like line M would be parallel to plane U because plane U and T are parallel. In the diagram above, line N is parallel to plane U. Sorry, I did the exact opposite of what it said, but same thing. M and N are parallel, so they're both parallel to U. So example 1. Think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? So which lines are parallel to ED and contain point C? So parallel lines mean they run the same direction and never touch. Well, ED is right here, and parallel to it is FH, AB, and GC. But in the instructions, it says it needs to contain point C, so there's only one such line that does that, and that's line GC will be parallel to line ED. Now they want to know which line is skewed to ED or lines is skewed to ED. Well, once again, ED is right here. Skew meaning it runs in the opposite direction, like up and down from it. So ED is running this direction, so lines that are running up and down would be BC, HD, FE, and AG. Well, for it to be skew, it can never touch line ED. So that puts HD out and FE out. But, also running opposite direction is BH, AF, CD, and GE. But once again, cannot touch this line. So skew lines would be the ones that are running not parallel and never touch it. So BC never touches it. It's So let's just go ahead and write that down. BC. BH. Never will touch it. AF. Will never touch it. And AG. Will never touch it. Okay? All the rest of them would either be parallel or touching the line itself. Okay, lines that are perpendicular to ED. Perpendicular meaning forming a right angle with it. Lines perpendicular to ED would be lines FE and lines HD, lines CD, and lines GE. Okay, and lastly, planes parallel to the plane ABH. So plane ABH is this top plane, this section right here, top plane. So to be parallel to that, it has to be running the same direction and right below it. So that would give us plane, let's call it CDE to keep our alphabetical order going, which is this bottom plane down here, okay? They're all blue, so I can't really say the blue plane. That wouldn't make much sense. Let's keep going. So parallel and perpendicular lines. Two lines in the same plane are either parallel or intersect at a point. So if you're on a flat surface, for example, my desk right here, I'll move the iPad, this flat surface right here, okay? Two lines can either be parallel, like this, go in this direction, or at some point they're going to intersect because they're on the same surface. Through a point not on a line, there are indefinitely many lines. Exactly one of these lines is parallel to the given line, and exactly one of them is perpendicular to the given line. So I'm going to do my best to kind of draw a little something here to give you an explanation of that. Actually, you know what? I'm just going to use the drawing that's already here, because what it's saying is line L is drawn, and you have point P. Right here on point P, you can have infinitely many lines going through it. For example, you have J running through it, K running through it, N running through it, and I could keep drawing more, but eventually it's going to get a little sloppy and it will look just terrible. So we're going to use their three lines they have drawn already. Through any point not touching the line given, there's exactly one line N that is going to be parallel, and one line, which is K, which is going to be perpendicular, okay? Those are the only two lines that can be parallel and perpendicular. All the rest of them, it may even look close, like, you know, you may have a line that is almost, but that's still not parallel. So don't get distracted by those lines. And right now we're going to learn about some rules about that, our postulates. So parallel postulate. If there's a line and a point not on the line, there's exactly one line through the point parallel to the given line. Okay? Just like we talked about. Perpendicular postulate. If there is a line and a point not on the line, there's exactly one line through the point perpendicular to the given line. Okay? Like point P, there's one line that is going to be perpendicular to L. Okay. So the figure shows a swing set on a playground. They want us to name a pair of perpendicular lines. Perpendicular means they intersect to form a 90-degree angle. So if we take a look at this swing set here, do we have a line, two lines that intersect to form perpendicular? And you kind of got to think of a swing set when you're doing this too. Well, if you look right here, DH and HI form a right angle there. So DH and HI form perpendicular lines. Now they want us to name a pair of parallel lines. Well, like I said before, it's kind of like railroad tracks. Well, here it's two chains that hang the swings. So if we look, we have FJ is parallel to GK. FJ J is parallel to GK. Okay, because they run in the same direction. Is DH, let's go ahead and look, is DH perpendicular to LM? Okay, so this can be a little deceiving because you're like, well, it kind of looks like it's running the opposite directions. DH goes up and down and LM goes the other direction, side to side. But in reality, if you were on this swing set, they're actually lying in totally different planes. Those two lines would never intersect. So the answer would be no, they are skew lines. Okay? Lines. They would never intersect. So I hope that makes sense. Feel free to ask me questions. Let's keep going. So, vocab word here, angles and transversals. A transversal is a line that intersects two or more coplanar lines at different points. So here are all these things, sorry, I drew on it. Here are all these things that we're going to learn when two lines are intersected by a transversal, okay? So the transversal is a line that connects two different lines. So the first thing we're going to learn about is corresponding angles. Two angles are corresponding angles if they have corresponding positions. For example, angle 2 and angle 6 are above the line and to the right of the transversal T. So I'm going to take a little time and do my best to draw all the corresponding angles. So these two purple angles are corresponding. 2 and 6 are corresponding. I'm going to do blue. So we have these two blue angles are corresponding. And then green. These two green angles are corresponding. So you have 4 different sets of corresponding angles when two lines are cut by a transversal. So now, the next one is alternate interior angles. Two angles are alternate interior angles if they lie between the two lines on the opposite side of the transversal. So here you have two lines that is cut by the transversal, and on the inside you have the opposite sides of the transversal. So 4 and 5, but you also have this little green angle, which would be whatever numbers they assign to it. But those two green angles are also alternate interior angles. So right there you have two different pairs of alternate interior angles that can be formed. Alternate exterior, two angles are alternate exterior angles if they lie outside the two lines and on opposite sides of the transversal. So 1 and 8 are alternate exterior angles, and so would both of these yellows would be alternate exterior angles. And lastly, two angles are consecutive interior angles if they lie between the two lines and on the same side of the transversal. So you have 3 and 5, but you also have these two gold ones. Okay, so here's what's really important. If I were you, I'd go ahead and just put this whole thing in your notebook, and I would write word for word what it is, and draw the pictures with it, because the pictures really help you remember what's going on. So in our next example, they're going to ask us to label all of the pair. I'll just read the question. Identify all pairs of angles of the given type. So they want us to write all the corresponding angles. And remember, corresponding angles lie on the same side of each of the lines that is cut by the transversal. So for example, 1 and 5. Okay? Angle 1 and 5. Angle 5. Also 4 and 8. Angle 4 and angle 8. Also 2 and 6. Angle 6. And lastly, 3 and 7. Okay? Like I said, we have 4 pairs of that. Alternate interior angles, okay? Alternate interior angles lie between the two lines cut by the transversal and are on opposite sides, okay? So 4 and 6 and 3 and 5, okay? Oops, I don't want to write and, I'm going to do a comma. Okay, alternate exterior, the opposite of alternate interior, meaning it's on the outside of the two lines. So 2 and 8 and 1 and 7. Oops. Okay, and lastly, consecutive interior, which are then be the opposite of alternate interior, meaning they're on the same side of the transversal on the inside of the two lines. So we have angles 4 and angle 5, comma, angle 3 and angle 6. All right, guys, that's the whole lesson. I hope it made sense. I hope you're following along. Yeah, so that's really all I got for you today. See ya!